Okay, so I'm going to go through everything that we've basically learned that you could possibly have on the quiz so that you're prepared. So the first thing I want to talk about is the degree. The degree is going to tell us like the maximum number of zeros that we could have, or just the number of zeros, I should say. And for this particular question, what is our degree? 4. It is when we look at the terms in descending powers, when it's in standard form like this, it would be that highest amount of exponents, so the 4. But that's only when it's in this form. If it's in factored form already, we would have to find the degree a different way. So that's only in this form, but that's what the quiz is going to be like. Okay, something else that we might be asked could be the leading coefficient. And for this example, the leading coefficient is -6. We might be asked to find end behavior. So if we have a degree of 4, leading coefficient is -6, that's going to be even, negative. Which means, so even would be like a parabola where they go the same way. Negative would mean it reflects. So they're both going down. The ends will be both going down. And then we write our end behavior as f of x goes down. So f of x goes to -infinity as the x values are negative. So I'm saying on the left side of the graph is going down. So the graph f of x to -infinity as x approaches -infinity. And then we have f of x approaches, no? -infinity as x approaches positive infinity. Remember the last two statements? Well, I should include the word as well. Maybe I should do this. All of this is always the same. When you do end behavior, everything I just highlighted in green doesn't change. It's always the same thing. The only thing that changes is what's happening with up or down. That's the only thing that changes. Is it going up or is it going down? Okay. Okay, so we also might be asked to find the, oops, wrong pen. The possible rational roots or zeros. It would be roots if I didn't have f of x. It would be zeros if I plug in 0 into f of x. Pretty sure they call it possible rational roots, but we're using them as zeros. So, and that's the p over q, the plus minus p over q thing. So I'm going to look at my p-values, which we're using 10. So we'll have plus minus 1, plus minus 2, plus minus 3. Nope, just kidding. 5, plus minus 10. And our, sorry, I knocked the thing out. And our q values, what number are we using? -6 or just 6? It doesn't really matter because we're doing plus minus. So I'm just going to look at the 6 part of it. So we'll have plus minus 1, plus minus 2, plus minus 3, plus minus 6. So now we're going to find plus minus p over q. I'm going to start with when P is 1. And I'm going to put when P is 1 over every single Q. So plus minus, the first one is just 1 over 1. Plus minus 1/2, plus minus 1/3, plus minus 1 over 6. Now I'm going to put 2, the P value that's 2, I'm going to put that all over my Q's. So plus minus 2, plus minus, okay, so my next one's 2 over 2. And what is 2 over 2? It's 1, but we already have 1 there. So you don't need to repeat it. The next one would be 2 over 3. So that one is new. And then we would have 2 over 6. But 2 over 6 is 1/3, and I've already listed 1/3. So I don't have to write all of those. Next, we're going to do 5. So plus minus 5 over 1, plus minus 5 over 2, plus minus 5 over 3, and plus minus 5 over 6. And none of those were repeating. And then we'll do 10 plus minus 10 over 1 plus minus, if I do 10 over 2, is that already here? 10 over 2? Yeah, that's 5. Do you have a question?
If you give it by like 1 over 1, 2 over 1, 5
That's fine too. Yeah.
I'm sure if the order you write it matters.
Nah, I'm just going to look that you have them all. So the next one will be 10 over 3. And then does 10 over 6 reduce? Do we already have that one?
Yeah.
Okay, so we don't need to write that last one. So how many answers do we have to work with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have like 12 of them, plus minus, so technically 24 possibilities. But those are just for rational. Remember, we could have irrational or imaginary ones too. Yes?
So if we write them, do we have to write, obviously, like we know there's plus minus between every single one.
Do it.
We want to
Do
split
it.
up.
Do it. It's going to be for like this chapter only. Never have to do it again. But that way, at least your next year's course, you've remembered having to write plus minus that many times. Okay. You know what, though? If I do this on the computer, I might have to change what I say because on the computer, you aren't going to be able to type plus minus. Maybe you will be able to. I'll figure it out. I'm trying to do this one on the computer tomorrow. Or, well, it's tomorrow for my other class, but for you guys on Friday. All right, what's our next category? We are going to look for positive, negative, and imaginary solutions, zeros. So we're going to look for the positive, negative, and imaginary. So then we're going to go up to the equation, which I don't want to I just copy it. I'll just cheat a little bit. Maybe, if I can copy it. It's probably already copied. Probably be fine. Yes. All right. Okay, good. So for the positive, we just go left to right and look for sign changes. Still negative. Still negative. That's one sign change. Still positive. So I have one total sign change. And then remember, for negative, we have to do f of negative x. So we're going to put negative x in every x spot. And then anytime we have a negative x to an even power, it becomes positive. If we have a negative x to an odd power, it's negative. So I'm just going to simplify. Some of these changes, some of these signs will change. Some of them won't. And then we look for sign changes. Yes.
The negative 86 squared be positive.
The squared becomes positive, but then it's negative times the positive. So what I'm thinking about is because this is positive, it will not change that sign. So that's what I was thinking of, and just copying that negative down. Where like the negative, how about this one? The negative 49 times negative x cubed. Since this is negative, it will change the negative 49. So that's where I got a positive 49. Okay, then I'm gonna make a table. I'm gonna go over here because of space. Make my table, and it'll be positives, negatives, imaginary, and then the degree. And I know that I have maximum of 1 positive and maximum of 3 negatives. What is the degree of this question? We already found it. 4. So it has to equal 4. So right now, if I have the maximums, then I have 0 imaginary. Done? Put it in there. But that 1 and 3 are only maximums. So I could have less. What up here has to be true every single time before I start subtracting numbers? What up here? There's something that's special. Nico? Yes. So the imaginary has to be in pairs. What's that mean for the numbers of the imaginary? Yes, when I find the answer, but in the column, like I could have 0. Could I have 1? No. So what's that mean about the numbers in this? Even numbers, right? Okay. So let's say that there were 2 imaginaries. Then what could be left for positive and negative? 1 and 1. 0 and 2. Is that it? Well, that's the next one. What about for 2s, though? Are there any more that have imaginary of 2? Okay, and then what was the other one that you said? 0, 0. And then we could have 4 imaginary to give us a total of 4. And then after that, there's no other options. So we only have 4 possible scenarios here. Finally, we can go and look at the graph. Let's type it in our calculator. Let's look at the graph. I already typed it in my calculator. That's what I was doing before starting the video. You guys, I don't know if you have, but it takes way longer for me to type it in anyway. Playing around to see what makes the graph bigger. Oh, there we go. All right, so let's start trying some zeros. Let's see. 1, 2, 3, 4. It kind of looks like -5 might be a 0. If it might be a 0, I'm going to do second trace, and I'm going to choose value. -5. Enter. And this thing is in the way. -5 is a 0. Yay. Okay. So, where am I? So maybe I'll label what I'm doing now. So the next thing we did was graph on the calculator. We used value, but we could use 0 Or we could use our table. I know some people like to use their table to find 1, 0. Find 1, 0. What do we do with that 0? Now that we found it, what do we do, Ryan? And I love how you said since it's a whole number, because that's what I was about to basically write. Use synthetic division if it is, and I'm going to say an integer, and long division if it is a fraction. And since it is that integer, what was it, -5? I already forgot, guys. Is it -5? Okay, so we're going to use synthetic. I'm going to zoom in so you can see my work a little bit better. So bring down the 6, multiply, and multiply, yuck. Did I do something wrong? I'll get a really big number here. No. Yes, thank you. You see, I'm like already knowing I've done something wrong. You might want to just think about things while you're doing it instead of just going through the process, but actually think about those numbers that you're getting. But yeah, I knew I was doing something wrong. All right, and then -45, and then 2, and then -10, 0. So if I had kept going with that accidental -95, I wouldn't have gotten 0 here. So that's why I knew that something was wrong. So if you get 0 here, you've done it right. I know it's -5 because I used my calculator. So I should get a 0 unless I've made a mistake. So let's go back to our calculator, because now what do we have to do is we're going to repeat. Let me write down the step first, and then I'll go back to the calculator. So we're going to repeat the process above until the degree left is 2, which is a quadratic. So we're going to repeat this process until there's only 2 left to find. So since we started with a degree of 4, I know I have to do 2 of those steps. If I started with a degree of 5, I'd have to do that previous step 3 total times. So going back to my calculator, I need to find a second 0. None of these look like they're nice answers, so I'm going to use the second trace 0. And I want to pick some. Now I already have the one it's sitting on. So I'm going to try to get this one. I'm going to pick something to the left of that, which is 1, 2, 3, -4. Enter. And it puts that little line up for me. And then I pick something to the right of it, which looks like -3. And now what I'm doing is telling the calculator to look only between these 2 boundaries. So we got to make sure it's around one of the zeros. And then it says, please guess for me. So it looks like it's -3.5. And it's not -3.5. That looks terrible. That is not a fraction that I know. Not a decimal that I know the fraction for. So right now, I'm going to think it's probably irrational. And I'm going to move on to the next 0. So second trace 0. To the left is -1. To the right, I think there's a 0 to the right. And guess it, maybe -0.1. I don't know, approximately. Of course I did this.
It's -1/6.
It is -1/6. I didn't mean, I literally just made this up before we were doing this, and I didn't mean to give you 1/6. I meant to give you something over 9 so we could use what we just did. We're going to pretend it's something over 9, but we'll write it down. It's 1/6. That's the real one. I'm not going to give you one that you can't figure out. Okay. I'm not going to give you a decimal like that you can't figure out. If I give you any repeating ones, it'll be those easy ones that are over 9. Okay. Sorry about that. But it is 1/6. Oh, look, it's 1/6, guys. You recognize that, right? 1/6. Okay. So we got x equals, it was -1/6, right? So that's a fraction, which means I cannot use synthetic division. I have to use long division. But before I use long division, we need to change this into a factor. To change it into a factor, we have to multiply by 6. So I get 6x equals -1, then add that 1. So I get 6x plus 1 for my factor. Because that's what we need for long division. Underneath, I do not use the original question. I use where I left off in the previous step. I'm going to use this -6, -19, 9, and 2. That was originally a degree of 4. I took out the -5. That should be a degree of 3 now. If you go back and you use the original question, you're not going to help yourself. We need to get this down to a quadratic. So we have to go from a cubic to a quadratic. Perfect time to review this. So I'm going to divide 6x into -6x cubed. If you can't do that in your head, you can write down -6x cubed over 6x. And like look at that and cancel stuff, and I get -x squared. And then I will distribute that -x squared. So I'm going to get -6x cubed minus x squared distributed. Then for subtraction, I draw the line and then I just change the signs, and now it becomes addition. I get -18x squared, and then we bring down 9x. Next step. 6x goes into -18x squared. If you can't do that in my head, I'm going to put it off to the side. When I divide those, I get -3x. We distribute that. -18x squared minus 3x. Draw the line, change the signs. So I get 12x, and then I bring down 2. Then my third one, 12x, need to divide it by 6x, and that's 2. I'm going to distribute 12x plus 2. Draw the line, change the signs, and we get 0. If you don't get 0, something's wrong. If you're confident about your, what is this thing called? Factor, then maybe you made a mistake in here. So now we have it down to a quadratic. What do we do when it's down to a quadratic? Of course, I use this whole page. Of course I did. What do we do when it's down to a quadratic? Or, so our next step is, oop, that's too small. When it is a quadratic. Factor, complete the square. Or quadratic formula. To solve the last two. So what did we get? Negative x squared. What was the next thing? No, you're making me look. Okay. Minus 3x plus 2. So if we're going to factor this, what should we do first? Okay, take out that negative. So you got the negative. If we're going to factor this, it's going to be x and x. The minus 2 means it has to be either a minus 2 or a plus 2, and either a minus 1 or a plus 1. One of them has to be minus. And then when we FOIL it back together, our outside and inside have to add up to give us positive 3x. So what signs can I put in these places so that when I add them together, I get a positive 3x? X plus 1x minus 2. So that's going to give me a negative 2x in the center and a positive x on the outside. Will that give me a 3x? No. It won't work at all. Okay, so if it won't work at all, what should I do? Quadratic formula or complete the square, but I would do quadratic formula for this one. Now, this negative that's outside, you can leave it outside and forget about it for now, or you could do quadratic formula with the negative factored back in, multiplied back in. It does not matter. I'm going to leave it outside. Come back to it later. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So 9 plus 17 over 2. So I can see why we couldn't factor it. It's irrational. So finally, we're going to write our zeros. Left to right, or smallest to greatest. And then we'll write factors in the same order. So if I go back to my graph, that's that, what was it, a 5? Yeah, that minus 5, that was the very first one. So we can see it on the graph. So x equals, we had negative 5. Then the next one was irrational. And when I look at my two irrationals, 1 plus, 1 minus, which one is going to be the smaller one? The plus or the minus? The minus. So I know the next one's going to be negative 3 minus square root 17 over 2. And then we have that negative 1/6 that I messed up on. Didn't mean to make it that, but that's okay. And then we have the negative 3 plus square root 17 over 2. So those would be our zeros, left to right. Okay, and then finally we'll do our factored form. And we're going to follow the order of the zeros. So if it's x equals negative 5, the factor is x plus 5. And then the next one, I'm going to subtract that. And it's going to change it into x plus 3 plus square root 15 over 2. Oops, 17 over 2. Sorry, 17 over 2. Sorry, I ran out of space. I didn't show the step where I'm subtracting it. I just did it in my head. Our next one is negative 1/6, which I had the factor written down when we did the long division. So 6x plus 1. And then our last one will be x plus 3 minus square root 17 over 2. Are we done? Or did we learn something last class we still need to do?
We need to multiply the thing, but I don't know how to do that.
You need to multiply what?
The denominator.
We don't have to multiply the denominators. We don't have to. But there is something we have to do. Because I'll tell you right now, this is not the real answer. Nico, what do you remember?
So you have to plug that in and see if it matches the graph in the top.
Oh, so you could use your calculator. But even before I waste all my time typing in the calculator, I can actually do something quickly here. You could use your calculator. Evan?
You can just multiply all the x's together.
We're going to multiply all, I'm going to change my color. We're going to multiply all the like first terms of each binomial together. So that would be x, 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 and 6x. So that would be 6x to the 4th. And double check that with our original question, which was negative 6x to the 4th. We need to stick a negative in there. Remember how I factored out that negative a while ago? Remember how I factored out that negative over here? That was actually one of the factors. So you could have maybe even not missed it, but I missed it on purpose because I want us to go back and check that. So really, I just need to stick a negative in here and then I'm good. And again, you have a calculator. You can totally double check on your calculator to make sure that they line up. Okay? So that, you don't have to do every single step for every single question, but that is all that you need to know for this quiz, which is kind of a lot, but that's everything you need to know for the quiz. So our assignment is a 9-question review. It's 8 pages, but please don't let that scare you. It's because I put like 1 question in a page, but you don't even have to do all of that step and all of that stuff in every single question, okay? I mean, there was one other thing we normally do is sketch the graph, and I'm not going to have you do that for this one, but I'll probably have you do that for the final one because literally you can see the graph. So you guys have the rest of the time to work on the review. If you have questions, come see me. I want to make sure that we are going to get really good grades on this one. Yes. Not many, maybe 2 or 3. Depends how much steps I do. Like what I was thinking about doing is maybe having you just do a P over Q thing or just doing the positive imaginary, whatever box, like just doing that rather than do the whole thing on one question. I know in the test, we do the whole thing on one question. So
What counts as a sign change?
if it goes from positive to negative or negative to positive, that is the sign change.
I know for one of these on the second worksheet, I couldn't get it.
Oh, okay. I'll look. I'm going to turn this video off.